This morning's job is to replace a condenser coil in this straight AC Lennox unit. It's under warranty. I think it's a 2016. 2014. But we're in the process of recovering. Down there, we've got a little ways to go, so it's just getting all my stuff out here. Obviously we got our condenser coil right here. Should be pretty simple. I'm going to go ahead and start breaking down this this unit, getting all the panels off, getting these little makeshift hurricane straps and things off, and yeah, get it ready to unsweat once we get it recovered. Well, she broke apart pretty easy. Like I said, it's a straight AC also, so there's not a whole lot of components or anything inside. You can see this coil's been pretty neglected. And if anybody was wondering, that's where our refrigerant leak is. It's actually on this bottom tube. Looks like it's rubbed against the base pan. So if it wasn't under warranty, it'd be pretty simple to fix. Unsweat it, flip it over, fix it, and reinstall. But since it's under a parts warranty, there's no real reason in doing that. When you're taking it out to fix it, you might as well just put a new one in. So that's what we're going to do today. She's almost recovered. Getting close. And the new coil, we're going to unsweat this discharge right at the bottom of that header right there. And it's going to be kind of hard to see, but there's a pressure switch down there, and there is a solder joint right in front of it. That's what we're going to unsweat and pull that out, disconnect that pressure switch, and that pressure switch is going to go on the new coil. We got her all recovered, guys. So now it's just a matter of hooking up some nitrogen and unsweating this coil. Like I was trying to show you before, I'm going to unsweat right here, because from here back, including that fitting for this pressure switch, is included on the new condenser coil. And then we're going to be unsweating that fitting right there. So pretty simple. Like I said, we're going to be reusing that pressure switch. You can see it can unscrew off of that port. So what I'm going to do is I'm going to go ahead and unscrew that. I'm going to put a refrigerant cap wherever I put them. I'm going to put one of these on top of it in its place. And then we're going to hook up the nitrogen, so I can just flow nitrogen and make sure it doesn't just escape here. Make sure it goes all through my condenser coil, so we can displace that oxygen so we don't have any carbon buildup in there. It does have a valve core in here. I wasn't sure if it did or not. We'll go ahead and remove that. Getting our nitrogen flowing now. I'm just going to put a little cap over that. We're going to open our suction side. Just let that nitrogen bleed out the other side. I'm I'm using the VN500, so I have the nitrogen turned up onto purge right now just to kind of flush everything. And now it's just down on the breeze setting, so it's only between 1 and 3 psi, just a little bit, which is all you need. Let's go ahead and toss some of this. This is Hot Block by Solder Weld. Just gonna toss some of that on there to keep that service valve nice and cool. See if we'll get this discharge line disconnected first. I think there's 2 fittings right there. It's kind of hard to see. Fire! Alright. Go ahead and sweat this liquid line down here. Up the nitro just a hair, help cool that liquid line valve down. And it's as simple as that, guys. Alright guys, we got our coil out of there. You can see here, got the coil flipped over. You can just see she's been rubbing. I don't see an actual hole. It looks like right there might be the culprit, but it's hard to say. So likely what I'm gonna do is put maybe a piece of Armaflex or something down here, or some cork tape, just to try and protect that coil so it doesn't happen again. Also, what I wanted to try and show, there, see how clean that is inside of there? That's from purging nitrogen. Without purging nitrogen, that would be covered in carbon buildup. So, super important to make sure you're purging with nitrogen, just so you can keep these units clean without contaminating them. And we got this cleaned up pretty good. Not perfect by any stretch, but cleaned up. So put a couple pieces of cork tape, as you can see, down in these corners, just to give it something between those two metal surfaces so it doesn't rub or corrode as quickly. And yeah, we're gonna go ahead and pop that coil on and get this bad boy brazed up. Just got it on a super preliminary, easy for me to say, pressure test, just about 160 psi. Just going through everything with the Big Blue, just to make sure all my fittings and everything, make sure that pressure switch down there, everything is nice and sealed. And also on that pressure switch, I did throw some nylog on there just to make sure we get a nice seal, and threw a backup wrench on there just to snug her down. But yeah, we'll give it a few minutes, make sure we don't see any bubbles, and then I'll be replacing that filter dryer, putting it on an actual pressure test, and getting her vacuumed down. Alright, she's all back together. I'm starting to pack up my mess now. Still got a bunch of stuff out here, but have it on my final pressure test now. Like I said, new filter dryer's in. Got my evacuation kit ready. Just on my final nitrogen test. 19 minutes and basically no drop. 1/10 of a psi. Holding at 382 psi, so we're pretty good there. But yeah, I'm gonna go ahead and finish packing up the rest of my mess, throwing this coil in the truck, and yeah, we'll get the VP85 out and we'll start this evacuation process. Just wanted to make this little update. I'm still pulling a vacuum on this unit. I'm assuming that the vacuum was never pulled properly, because we got down to 2,000, 1,800 really quickly, and then we pretty much stalled out. So what I've been doing and what I currently have is I have the system isolated. So I have the Appion core removers closed. Not sure if you can see that. That one's closed, that one's closed. And I've just been letting everything naturally rise. And we started to slow down to almost stop, but this gives you a good idea. You can see this long broad arc right here where it rose and then it started to turn and level off. You can see right here we're still rising at 0.3 microns per second. So basically what this kind of arch shows you on the Blue Vac is that the system has moisture in it. If this arc were to just steady go up at like a 45-degree angle and just constantly rise, that would tell you that the system has a leak in it. We know it doesn't have a leak in it because we pressure tested it at 382 microns, or excuse me, 382 psi of nitrogen for about 30 minutes and only had a 1/10 drop. So just wanted to get that on video. You can see it's starting to slow down even more. It keeps going down to 0.2 microns, 0.3 microns per second. But just wanted to show that arc right there that's slowly starting to flatten out. It just tells you that you still have moisture in the system, so you need to keep on evacuating. So occasionally, once I stall out, I'll isolate and let everything rise back up. Just make sure that I'm still dealing with moisture, kind of give it a little bit of time for any moisture to boil off in there, and then I open the lines back up again and continue on with the vacuum. So I'm going to go ahead and open these lines back up again. Last time I got down to right around 550 microns. But sometimes you just gotta, if you want to do best practices, sometimes evacuations take a long time. When the system's new or the system's nice and dry, you can pull them down really quickly. But like I said, I'm assuming that best practices weren't used on this system when it was originally installed, but we'll get her pulled down. So I'm going to give it a little bit of time, let her pull back down again, see if we can get her down under 500 and stable in our decay test. And yeah, just got to be patient. Now you can see we're down under 500. You can see we rise up and then it'll drop back down again. And like I said, this is just an indication that there's still moisture in the system, so we're going to be patient. We're going to pull this bad boy down as far as we can. We do have a new dryer in there to pick up any moisture. Like I said, best practices were definitely not used when this thing was installed, but we'll get it down as low as we can before we perform our decay test and charge this bad boy up. But I thought that would be good to get on video. Like I said, every evacuation, every vacuum isn't perfect, especially in the real world. Not everything's in laboratory tests, so when best practices aren't used on an existing system, sometimes it makes it hard for the next guy coming out doing repairs. But we'll get her down as low and as dry as we can before we charge her up. Alright guys, we are back up and running, all charged up. We're dealing with a piston out here. So we have an 88 outdoor dry bulb and a 68 wet bulb, so we're looking for 17.5 as our target superheat. Let's see if you can see that. Plus or minus 3 degrees for 410A, so we're sitting pretty good right there. 9.7 subcooling and 19 superheat, so may put a splash more in it if the superheat rises too much more, but we'll give it a few more minutes to steady out. But pretty happy with those numbers. One last thing I wanted to mention when it comes to recharging or charging systems, adjusting refrigerant charges, this one doesn't have it, but a lot of times you'll see a required subcooling on the data tag. That is only to be used when you're dealing with a TXV metering device inside. When you're dealing with a piston, disregard that requires subcooling and focus on your target superheat. A lot of times if you're chasing that required subcooling, you'll end up overcharging a system depending on the conditions. But for this one, like I said, my target's 17.5 superheat. We're sitting at 19.1. Once you get that into range, then start looking at your subcooling, which will give you an idea of how things are performing. So in this case, everything's looking just fine. So, but yeah, just keep that in mind, guys. That target subcooling on data tags is only for a TXV metering device. So just keep that in mind, guys. But I'm gonna go ahead and wrap this one up. Looks like we're hanging tough right there, 18, 19 superheat. So I'm happy with that. So gonna go ahead and pack up everything, write it up, and get on to the next one. So thanks for watching, guys. Hope you enjoyed the video. Like, comment, subscribe, and we'll see you on the next one.